Well, gentlemen, welcome. We're going to fix a problem. It's a problem that most people don't even realize they had, or I have, on this workbench. And it's this. These connectors, that one, that one, that one, and especially this one I found out a couple weeks ago. This one went kapoo and blew out. And what I mean it blew out, as in like the PL259 exploded out of the end of the connector. It was when I was working on a 3000 for that my gentleman, my friend Mike over in Ohio. I was taking him that 3000 that I built, the Hellraiser. Excuse me, I built that many years ago, and you know, you guys have seen me struggle with this. I had one video that I did here a couple months ago where I took the bird meters off and I put them on top of the amp, and even at that, the coax and the dummy load itself were getting so hot that I was having SWR rise issues. Now, this is not something that I deal with on the daily. Absolutely not. But since I had this fail the other day, I went, well, maybe I should do something about it. And so my solution is that we're going to convert everything from this connector down to LC. And eventually we're going to convert all of this. Just takes money, right? But eventually we'll convert this up to LC as well. And then I'll have this contraption going on, which is how I take LC down to a PL259. Let me take the protectors off this thing so you guys can actually see what it looks like. This contraption here is how I can hook the workbench into the antenna, right? Then I have another adapter that goes up to 2 1/4 from this, so I can hook it into my antenna, because my coax on my antenna is 2 1/4. But this is, I mean, to give an idea of scale, right? This is a PL259 to LC. These are all bird parts. Right, there's probably 100 and, I don't know, 150, there's several $100s here and just in my hand. As you can see, it says bird on it. Spendy parts. These are all Spendy parts as well. This stuff, surprisingly, is not too bad. It's only about $9 a foot, $8 to $9 a foot, depending on who you buy it from. There's two different versions of this. They make a single shield and a dual shield. This is a dual shield. Center conductor is the same size, which is a solid piece of copper. So we're going to take and run this down to the dummy load. That way I don't ever have to worry about this thing deciding that it wants to let it shmoo out of the connectors ever again. I kind of talked about this on Facebook. I've thoroughly covered this on my Patreon. But we're going to upgrade this tonight. So our first step that I'm going to do is we're going to take this brand new Bird LC connector, which if you buy these from Bird, this is missing a couple pieces because I don't use them. One of the pieces is how this whole thing goes together. Is this fitting has this reduction collar, and we take the tapered bit, we slide it inside, and then we fold our shield over. I'm going to show you how we do the connectors on this. And then this, the tapered tip, threads into the back of the... Man, I got a case of the dropsies tonight. So the tapered bit we thread into here. Pardon me. Taper bit points down, the flat bit threads into the connector, and that's what pinches your shield in place. Now, if you've ever noticed, if you've ever had any experience working with these, you'll see that there's a little bit of a gap for the support collar. And what that's actually designed for is that there is a sock, a wire mesh sock. Hold on, let me grab one for you. I'll show you what I mean. There's a wire mesh sock, strain pull relief sock that fits down inside this thing. It fits in here like so. And then we slide this over to coax, and it puts its weight It helps support the weight of the connector so you can have this hanging in a commercial application. This is kind of like your Chinese fingers that we used to get at the Chinese restaurant when we were kids. The harder you pull, that's never going to come off. So they make these in lots of different sizes. Let me show you what I mean. This is a much bigger one. This is a spare that I have from when I was hanging the coax on my station. So you take your, this is designed for 2 1/4 inch heliax, and you spread this out. You spread out this collar like so. See how this goes from very small to very big? So you shove your coax up through this, and then you have your hard bolted attachment point for your coax on your tower, so then your coax can hang, and it spreads the weight of the coax over the shield evenly and uniformly, and it allows you to suspend like 25 or 30 feet, or in my application, three 20-foot lengths of 2 1/4 heliax out. Well, we're not using this. We're not going to use this. And we're not needing to use this. So that's the reason that the sock is removed. But I want to be as thorough as possible. When I went to go learning about some of this kind of stuff, I had exposure to this and commercial fittings like this. Most of them were 75 ohm. Some were 50. When I was working in the cell tower industry, it was all 3 1/8 or 3 1/2 or whatever it is. Heliax in the cell industry, and it was 7/8. Lots and lots of 7/8. My God, so much 7/8 I've strung up in there in the air when I was a kid. Lots of coax socks, lots of grounding, bonding clamps. But what we're working with here today, we don't need that. So this piece goes on first. This piece, which fits smooth to the coax, goes on second. Then the reduction collar. This goes on after we get the jacket off. And this sits at the top of the connector. This orange insulator is our crush point. So I like to use a setup more like this. Grab this old jumper off the floor here. There's a pin that goes on the inside of this, and then there's a piece of nylon that would fit inside of here. So you put the pin on, you solder it, or hydraulically crimp it onto the end of the coax, and then you put the nylon over it, and then this all slips through. Well, us CB operator, amateur operators, we're kind of resourceful people. So you don't need to use this Teflon spacer. You can just use the coax, because this is hard nylon, otherwise referred to as neoprene. And if you don't have that center pin, you can just use the center conductor of the coax. Now, there's some positives and some negatives to this, just like there is in everything in this world. I prefer to use the center conductor of the coax, because I have found we're not in a commercial transmit environment where, let's face it, some radio operators, I'm just saying this out loud, some radio operators on the face of this earth have to get every last schmook and watt out of things, and then they'll run things, especially coax. CB operators are so abusive to coax because to them this is a huge expense. They'll spend $30,000 on their amplifier, but then when somebody says to them, man, I want to spend, you know, you better spend $2,000 on coax, their brains go and they melt down and they can't handle it. The metal pin that's on the inside of this thing, technically, in my mind, in my uneducated, tismed mind, that pin, because you're taking the pin, you're now crimping it onto this connector, which is the exact same size as the center conductor, by the way. It doesn't screw up the connections at all. There's not as much surface area to transfer the energy from A to B on the connection. So you have this little tiny cup that slides down on top of the center conductor, and then you're supposed to either hydraulically crimp it or solder it. I personally don't want to use it. I've had them fail, where that one tiny little boot that fits on here will burn. It'll get so hot because of the differentiation in metals, it'll burn up. And then we start having all kinds of problems, like, here, let me show you another example. This is your standard PL259 barrel connector. Here's your standard LC barrel connector. Little difference, right? This is what your LC barrel connector looks like when you put too much schmoo through it versus this, right? Some bitch been on fire. You can see the nylon on the inside of it's gotten so hot that it's melted. This right here, this is what happens when you put 60,000 watts through an LC connector. Dead carrier, 60 grand. Well out and beyond what any engineer that ever set forth the idea of using this. Now, some of you guys might remember when I burned this up. This and this are the same failure. This was in here like so, and this end piece, which is these two bits here, this end piece was stuffed inside that barrel like so. Please note, the only part that isn't burned is the center conductor, but everything else let the smoke out. I don't know. I show up in forums sometimes and I'll make a comment. I'm like, dude, you don't want to do that. Why not? Well, because I've had that fail. You don't know what you're talking about. I got data sheets that can handle it. Okay, but I've had that fail. You don't know. Well, I guess data sheets are just made for... No, I'm telling you that the data sheet works in this thing called an ideal world where you and me and most radio operators, we operate in this theoretical max limit world. So if I tell you something's going to fail, it's because I've had it come apart on me. This jacket is supposed to all be this color. This is all burn. This is RF going bzzzt, and it jumping from the center of the barrel out to the body of the barrel jacket. So what I did as an interim fix until I upgraded the size of my Heliax is I took the pin that was in the side of this one and I pushed it out. There's just a tapered hollow tube with some sleeves and some finger stock cut in it. And I pushed that tube out, and then I made one out of brass. And then I took another barrel I had and I actually changed. This is not in use anymore. I took and I chucked this up in a lathe and I drilled this out. And I changed it so that the metal mass was almost twice the amount that was inside the barrel, because these barrels are expensive. You can find them on eBay for relatively cheap sometimes, but if you want out to go buy this barrel connector on its own, this is like $500 or $600. This is not what I paid for this one or this one, and none of these connectors is what I paid, you know, the full list retail price for them, because you can find this as a backup spare for my current fitting. This is so you can pressurize your coax with nitrogen, but we're not using that. This is very common. Most guys that are doing pair of 15s, pair of 20s, that kind of thing. I'm on a 40, which is basically like having three 20,000s in a box in one tube. This is a very common 1 5/8" flange is where most CB radio operators line out at. We can go. How rude. I got way down on this TISM thing and then I realized the mic had cut out. So this is where most CB operators end up at, is this connector. I mean, that's some girth. This is a bullet. This is what goes on the inside. So this is our current state of affairs. And still technically that's too small. If we notice the bullet, to give idea of scale, most radio operators, ham operators, whatnot, to give an idea of scale, the bullet, this piece, which is the same piece, is bigger than your whole PL259 connector. That's just the center conductor. And shit only gets bigger from here. So how this works is you've got your 1 5/8" line section. Right, so this would be like the end of your bird line section. Mine's coaxial dynamics. The bullet fits into here, like so, right? You bolt the two together. The downside to this fitting is, once again, surface area and size, okay? This 7/8 adapter is beautiful. I got this from Bulgaria. Is where I ended up having to buy this, because I thought, I thought in my mind, I'm never going to go as big as I ended up getting. This, to try and take this and reduce it down to this, it's not much bigger than this. Okay. So we're keyholing ourselves into the same positions, which is hence the reason why I got rid of this adapter, right? That's all this is an adapting flange, and went to a direct bolt. That's what you have to do. For most guys that are in the amateur world or in the CB world, this isn't necessary. Like I said, this is my coax that I'm currently using. This is inch and whatever. No, it's two and a something or other. This is our down fitting, right? So this came off the line section, this plugged into this, and ended up replacing both of these things. So I'll put them in here for scale. And I went to this. I was able to eliminate all these extra connections, which all that is loss. I was having a conversation with one of my friends and a student tonight about coax connectors and loss. And when you start adding up things, and heat loss, and when I mean loss, I should do a video on this. Loss is expressed in so many different ways, right? You have your fitting loss, which is heat, and heat, and heat, and heat is loss, right? So if your coax is getting warm, that's loss. You want your coax to be as cold as humanly possible. This here, single 15 all day long. You're pushing your luck on a 20. Pair of 20s, no, this will not hold. This will eventually melt, okay? So when we go to this style of center conductor, we need to have the appropriate center conductor on the other end, right? It only gets bigger from here. This is 51.5 ohm impedance. This here is a 3 1/8 or 3 1/4 line section. Look at how big the bullet is. The bullet's the center journal. Look. Once again, it's like Debbie. It's like Debbie when she came home from spending a couple months in Dallas in high school. Okay, there's significantly more center conductor there. Needless to say, the 393, and I'm sorry I went down this TISM rabbit hole on you guys. It has nothing to do with what I'm doing now. I was just trying to share more knowledge. The 393, or RG393 coax is amazing. You can put a billion watts through it and it won't fail. As in, like, it won't burn up, physically burn up, but it will get so hot that you can touch it and leave your fingerprint on it. I've had that happen. I had this fail because the PL259 said, no, F you. It usually happens at about 10,000, 15,000 watts peak, which is pretty common knowledge. And most Channel 6 operators, this information that I'm talking about now is common daily knowledge. The words that we're using, the lexiconian of what we're talking about now, this is normal word culture for the world that we're in. Most amateur operators will totally be fine on this little guy. No problem at all. Like I was saying in the previous segment before the mic cut out, the only reason I ever went as big as I went had nothing to do with anybody local to me. With all due respect to the one gentleman that's on the radio here locally, man, he on a pair of 3500Zs or a pair of 800s or something, right? I don't know what he's on. I don't care. It's not my damn business anymore. It's not my job to keep him running anymore, thank God. We've long since divorced that relationship, which I'm very comfortable with, by the way. I moved on because I wanted to continue growing my knowledge base, right? So when I first started out, I was keyholed by the knowledge of the people that were here in town, and that eventually grew, and then I was able to get more knowledge from people that were not here that actually know things more than what the guys here knew. The people I was learning from here locally, they shared with me everything that they could possibly teach me to the end of their knowledge, and I had to go find better knowledge. So the very first step was this, had this fail, obviously, It held in there. I was able to run a single 15 on it for about a year. It held together for that. But then when I decided to go and run a 20, then I started having failures. And then when I went to the 40, it was, stuff was failing so violently and with so much flame and stuff that it was like I needed to upgrade. The reason I went this direction instead of bigger is because this is about as big as you can go and still have a prayer of bending it and it not kinking itself, right? This way. And this in turn brought on some of its own problems, but it's okay. They're problems that you can mentally work your way through, right? So let's clear all this off. Let's get all these fittings out of the way, and let's focus on getting this end put on, because this will be the one that's actually plugged into the Bird 43. In an ideal world, I would probably be on a completely different line section on this workbench. But then everything I would be doing here would be involving equipment that you, the end user, the most people at home, won't have a reference to, right? Like you won't have a physical eyeball on target reference. I know I'm going to do this video. I know that we're going to get a couple thousand views on this video, right? That's the end of the scope. Even though I've spoke about it on video, no one's going to go back and watch that video to get caught up to where we're currently at. So I have to keep things here because 99% of the work that I do is going to be several thousand watts and down, right? Only a very select videos where I'm doing 10,000 watts and above. So I have to keep things here within a realm that everybody's visually comfortable and understanding what they're looking at, if that makes any sense. Because I have to pander to that main audience, right? Just saying. The dummy load's a 10,000 watt continuous dummy load. I've only got it hot enough to chip on the fans twice. And one of them was intentional. I literally took my 40,000 and dumped it into the 10 because I wanted to see if the thermocouple that was in the dummy load that turns on the auxiliary fans, that forces it into cooling mode, if those worked. That was one. And then two was about 2 months ago when I was playing around with my 3000 that I sent to Brian Smith, and I was making it do like 26,000 peak watts and like 11,000, 12,000 bird, which you should never push a 3000 that hard. I said that in that video. I'm saying it again now. You should never, ever, ever push your 3000 that hard. Ever. Like ever. But it's fun to do if you have enough power supply and you got the right connectors and enough driver and you're in a safe and controlled environment and you're not going to try and operate it like that on a you're trying to show the maximum operation of the box, right? So it's fun to do that every once in a while, but that's not how you can run it on a daily basis. So this 393 has put up with a lot of shit over the years. Let's face it, there's been a lot of watts go through that piece of coax. I've had 4 different pieces of coax on my bird meter setup. I've had 217. I've had 393. Let's see, I've had the big, I had, in the beginning I had 213 because that's all I could afford. Of course, that was going to a 1,000 watt, paint can dummy load. We've come a long ways in the last 14 years since we've been out here together. Like literally my whole arc and radio and all the things I've learned and taught and everything, it's all been here on video for you guys. We've come a long ways together. So let's get all this shit cleaned off. Let's get this end put on. It's just going to take a few minutes to modify up the bird meters as far as we're going to be able to take it today. I screwed up. I didn't order enough connectors. I thought I did. I thought I had more stuff than what I did. Because like I said, I left the LC universe 7-8 years ago. And so I've given away a lot of connectors and stuff and forgot that I gave them away. But I have more stuff on order. More is coming. So from here to here is going to be PL, but then from here to here is going to be all LC. All the way down to the dummy load, which I feel very comfortable, very, very comfortable, very, very comfortable that it's not going to fail me. There's a whole YouTube video on me getting this dummy load. I bought it used. I got it from my friend Charger over at Fatboy. It was very beat up. I ended up pounding out all the sides on it and cleaning it all up and repainting everything and putting all new hardware on it and replaced one of the fans. But this is my 10,000 watt dummy load. This connector since day one has given me fits. I cannot wait to do an autopsy on that one, because every once in a while I'd be testing something and all of a sudden I go, and my reflect would go bing into the corner, right? And it has something to do with this fitting. I bought that fitting from a guy at Puyallup Hamfest in Seattle one year. Actually bought 2 of them. And it's actually designed for like 1/2-inch heliacs to be adapted down to an LC connector. So this thing's actually designed to do what I'm using it for. So I took the whole connector apart. This guy ended up dying the next year at that Hamfest with a heart attack. He literally dropped over dead, but that's another whole story for another day. This fitting right here is, I've had some problems with it. It's arced on me a couple different times, and I just reach down here and I kick it with my foot. I just kick it and it'll move, and then it won't arc, and then I continue on. Hey buddy, my dog's trying to get in the video too. So we're gonna replace everything from this 90-degree elbow up to the workbench over here. We're gonna put all brand new stuff in play here today. And that's the way it's gonna sit from now forevermore. So I thought I'd cover it, explain 1, why I'm doing it, 2, how I'm gonna go about doing it, and 3, what's the things that we should think about while doing it. So I think we've achieved that. Okay, so as I covered in the previous video segments, we have our 2 other collet pieces that we've already installed. It's just like putting the downsizer on a PL259. We're going to strip the jacket back roughly, looks like this is going to be about 2.5 inches is how far we strip the jacket back. So about 2.5, give or take. Don't really matter, you can trim to fit when you're done. So you take the dual shield and you're going to splay it out, fold it out, just like you would a regular adapter for a PL259. Okay. Then you take your scissors and you're going to trim the shield around. The only place that the shield is going to make contact's right here. And it gets pinched between this flat edge here and here, and then there's a little rubber gasket that sits in here too. We'll cover that in a minute. So you flay that out. Now to make it work without the nylon connector, we'll use this as a reference. You see how much of this pin is actually hanging out here on this connector? This is a bird put together connector. So we'll get out our machinist ruler here. And this comes out to 16 on the machinist ruler. Well, I like to make them a little bit longer than that, because I'm going to show you what I'm going to do to it here in a second. So we're going to make this just a little bit longer. Just a little bit longer. We're not going to have the nylon stick up this far in the connector, by the way. That's the other part. We're going to make it flush with the finger stock that grabs the inside of the connector. There's a little finger stock in here that press out. So when you go to slide the connector together, it helps make a better ground bond. So this works out to be about a little bit over 1/2 inch. So from the shield down, we're looking about 1 1/8 of length. So when we slide this together, it's going to look like this. It's going to look like this. See how the nylon comes directly up to the edge of the stock? It's just me, it's a personal preference. Yes, we can have it where the nylon comes a little bit past the end of this. I haven't seen any pros to that. I guess in the ideal world we would understand that this allows us to have a little bit more insulation, because now the high voltage that's traveling on the center pin has got to crawl back over this Teflon surface. I'm good. Air makes a decent insulator, and the power level that we're going to be at, it's not a big concern. So before we go and we put all this together, of course we're going to blow it out real good. We take our file from when we cut or cleave this. There's actually a really sharp edge here. So what we're going to do is I'm going to take my file and I'm going to sit here and I'm going to go all the way around this thing. I'm going to smooth that edge off and make it so it can go through the connector. Now, I know files only work in one direction, and I know I just drug it in the wrong direction. There's somebody out there that's going to mention that. I do know the difference. The idea is to round the end of the solid copper conductor down to where it looks like this thing, nice and round. So let me get to filing. Give me just a minute. Okay. So now we're all nice and round. The exact same diameter, by the way. So the only thing left to do now is to put the connector together. This involves a couple different crescent wrenches and a pair of pliers. Very simple. It's twist, twist, crush. Get her done. So let's get this done, and then we're going to move on to do the birds real quick. And because of the sheer girth of this cable, I'm not going to be able to have the coax just simply dog out and go straight down and go to the dummy load. I'm going to have to run it along the wall and run it down the edge of the bench and then over to the dummy load. But for our testing purposes, it won't change how this operates in this setup whatsoever. So let's get the connector on here. Let's get done with this, because I got to go work on a 1, 2, 3, 4 pill after this. So 3.8 milliwatts worth of reflag. I can live with that. So what I didn't show in this video was how I went about nulling out the coax length going down to the dummy load down here. It's all nulled. It might have involved this block and a barrel, this block and a barrel connector and a network analyzer. And no, we didn't cut it for resonant frequency length. We literally nulled it out for zero reactance, which is a conversation we can have on another video. It's not a conversation we're having tonight. So that is upgraded. What you will see change in the future is that we're going to have LC from here out to the 90 degree come in this direction. One of the things I want to do tomorrow is I want to upgrade this. This has been long overdue. This took forever to get. Is I want to upgrade this the voltometer, or the volt amp meter. I got a brand new panel meter that actually fits that opening. I changed out the meter shunt and a couple other things. Just another couple hour project to do that. So we'll be back. We're not done yet, but as far as this connector, deciding that it needs to catch on fire and leave the chat, I don't think I need to worry about that again for a while. Of course, if I ever end up testing anything bigger, I wouldn't test it with these little meters. It would have to go to the 1 5/8, and then we're talking remote meter movements, and it gets more complicated. So it's okay. I mean, it's complication that we can handle here, but it's not anything that I need to address today. So on that note, gentlemen, I appreciate you all tuning in. Got questions, comments, anything I can ever do to help any of you with anything that you think I might have an answer for. If I don't know, I will simply tell you I don't know, but then I'm going to steer you in the direction of the person I think would most likely have the answer to your question. But for most of your everyday plain Jane BS, I got you covered. Gentlemen, my name is BBI, and if you can't tell, I'm not too overly enthused. I didn't want to have to do this project. I've put it off for years and years and years. But this connector blowing up made me do it. It made me do it. I appreciate you guys. I'll see y'all. Click, click. On a quick side note, when the thing blew up, I didn't have any time to dick around with it. Like, I needed to immediately fix the coax and verify that the amp was still working and that I hadn't damaged the amp. I had to completely disassemble the amp again and make sure none of the relays are damaged or none of that stuff. So I simply slapped the new parts back on there, got a new PL259 put on it, and got on with it. And then I had to get out of town the next day. So this wasn't something that I could sit here and do a whole YouTube documentary on. So I apologize on that. In the future, if I have a connector blow up, I'll do more videos for drama's sake. But when it went down, I needed to get out of town. So I apologize, but the end result is we're upgraded. On that note, I'll see you guys. Click, click.